This is the solution for the practice problem set 3 for ME 347. So the practice problem set has three questions. The first question asks the students to rotate rotate a given point by 60-degree angle uh, about a line which has the direction cosines 1 by root 2, 1 by root 2, 0, and the line passes through the origin, which is 0, 0, 0. So that is the first question. Second question requires the students to rotate a cube of unit length um, with one vertex at the origin. The students are asked to rotate the cube by 45-degree angle about the x-axis and project the cube on the xy plane and determine the final vertices. And for the third question, the students are asked to find a quadratic curve that passes through the given 3 points. So to solve these questions, we obviously have to look at the lecture video. Um, for the first question, the students would have to watch the lecture videos titled 3D rotation underscore align underscore 1 and 3D rotation underscore align underscore 2. So these two lecture videos solve the question of rotating a point about a line. So to solve it, the given direction cosines nx, ny, nz of the line is 1 by root 2, 1 by root 2, 0, and it passes through the origin, which is 0, 0, 0, and the point which we have to rotate is 3, 4, 4. So the first thing to do is to make the line coincide with one of the axes. We choose the z-axis. So we use the two rotation matrices Rx and Ry, and we find the components of the rotation matrix cos psi and cos phi using the given formulas here, which can be calculated with the direction cosines given in the question. So we get that cos psi is 0 and sin psi is 1. Sin phi is 1 by root 2 and cos phi is also 1 by root 2. So we get the two rotation matrices as given here. So applying these two rotation matrices puts the line to coincide with the z-axis, and then we rotate the point by the desired angle, which is 60 degrees. So the rotation matrix follows as follows. Um, RC is equal to cos alpha minus sin alpha 0, 0, sin alpha cos alpha 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And since alpha is 60 degree, the numbers come out to be 1 by 2 minus root 3 by 2, 0, 0, root 3 by 2, 1 by 2, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So now that we have all the matrices, we can apply the matrix operations on our point P as given. So we rotate it by Rx, Ry to coincide the desired line with the z-axis. Then we rotate it by the desired angle using the RZ, and then we put it back to where it belongs using Ry inverse and Rx inverse. So finally, we get the coordinates for the point after the rotation to be 0.44, 4.95, and minus 3.18. So that was the first question. For the second question, we are asked to rotate a cube of unit length with one vertex at the origin by a 45-degree angle with the x-axis, and project it on the XY plane. So to solve this question, we need to watch the lecture videos on 3D rotation as well as the orthographic parallel projection to solve where similar kinds of problems are solved. So solving the question, we know that the cube has one vertex on the point origin O 0, 0, 0. Then we assume the cube is placed in the positive octant in the 3D space. So there are eight vertices for a cube. So each vertices are found to be, and we know it's a unit cube. So it's like it's just the length of each side is one. So we get the eight vertices of the cube as follows: 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, and 0, 1, 1. So these are the eight vertices of the cube. Now we find the rotation matrix. Um, so the angle psi is 45 degrees. So we know the rotation matrix for the rotation about the x-axis from the lecture videos as follows. So when we substitute the angle 45 to the formula, we get the rotation matrix as follows: 1, 0, 0, 0, 0, 1 by root 2 minus 1 by root 2, 0, 0, 1 by root 2, 1 by root 2, 0, 0, 0, 0, 1. And we represent the cube with the matrix C. You can see that each vertex of the cube is being represented in the matrix C. So uh, it's an uh, it's a 4 by 8 matrix. Now from the lecture videos, we know the projection matrix for projecting a 3D object along the XY plane is this. Given here 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Notice the third row is all zeros. That is how we eliminate the z coordinate, the z coordinate, so that we project it on the xy plane. So the transformation happens as follows. We first rotate the cube and then we apply the projection matrix to project it on the xy plane. So finally, we get the projected vertices. Notice that the z coordinate for all the eight vertices are are 0. Um, we can see that there are several points that coincide on top of each other, which is expected when you project a 3D object to a 2D space. So this is the final matrix for the cube after transformation. So that's for the second question. For the third question, you're asked to find the quadratic curve that passes through the points uh, 1, 1, 2, 4, and 3, 8. To solve that, you need to watch the lecture video, curve interpolation. The file name is interpolation underscore poly. So solving that question, we have the 3 points. We separate the x and the y co coordinates out and we write them separately. So we get y0, y1, y2, and x0, x1, and x2. We are asked to fit a quadratic polynomial. So the formula is this: a0 plus a1x plus a2x squared. So we need to convert this equation into a matrix form. So we write the matrix form of the equation: a dot b is equal to c. So the A matrix is this. Um, the first column is just ones, uh, that represents the A0. Then the uh, x of degree 1 and x of degree 2 are written in two separate columns. So x0, x1, x2, x0 square, x1 square, x2 square. The matrix, the vector b is a0, a1, and a2, and the resultant of their multiplication is the y points, the y coordinates is y0, y1, and y2. So substituting for x0, x1, and x2 into the matrix A, we get the following matrix, and uh, we know the values of y0, y1, and y2. So when we do, so we need to find the vector b, that is the a0, a1, and a2. Um, so Uh, we get that by multiplying the vector c by the inverse of the matrix A. So when we do that, we get the answer to be -1, 3 by 2, and 1 by 2. So the equation of the curve that passes through all the 3 points is y is equal to -1 plus 3 by 2x plus x squared by 2. So that is the solution for the third question.